Good morning. Today we'll be talking about some statistics. Let's briefly review what we discussed last time. Last time we talked about modeling and assumptions, and in that slide we talked something about two sample test. What is two sample test? Two sample test is about taking two population of random samples. That's the first step. Second step is to do some calculation on those samples and then compare those calculations to one another. In one sample, we will use as a reference, and other samples will be actually doing some testing that we want to prove or disprove. This is how majority of hypothesis testing works. There are times when we don't need two samples. For example, let's say if you have established benchmark in our knowledge base, then we don't need two samples. For example, let's say we are trying to compare the speed of a new model of car to its previous model. We already know that the speed of the previous model is established. Let's say it's 180 miles per hour. Now what we are doing is we are calculating or comparing the speed of new model with the old model. So we don't need to sample in this case. We can just use the sample from new model and compare that with the sample from previous model. So that's how it works. But majority, in practical majority, there are two samples. Now let's focus on our today's topic. We'll discuss about heuristic of doing hypothesis testing. In the first look, we can simply say that we'll take the mean of sample from the first sample x, and we'll take the mean from average from second sample y, which have both different number of population. And if x is the mean from x sample is greater than mean from y sample, they will simply say that mu1 is greater than mu2. What can go wrong here? There are a few things can go wrong. Let's say when we are taking sample of x and we simply took the flights which were empty or very less which has really few passenger. On the other hand, when we took the sample of y population and we took full flights, then at that time mu1 will not be larger than mu2, or in fact it may be case that mu2 will be larger than mu1, because mu2 represents the expected mean of y, which is full flight. Hence we can assume that the average time of boarding those flights will be larger than the empty flights, which is of x. To deal with this kind of variations, fluctuations in sampling, we need to do some we need to have some error margin or buffer. Specifically, how do we do this? For this, we need to take some buffer, and for that we'll add buffer in, we'll subtract and add the buffer in both sides of the equation. How do you do this? We'll subtract buffer from x, which is the one side of the equation, and we'll add the buffer on the other side, the margin on the other side. What we are saying is that, even if we subtract a certain amount of value from x, and if we add certain amount of value on y, and they are still greater than, there is still inequality between them as we expected, then we can say that mu1 is greater than mu2. This is x, just pictorially, this is x and this is y. Let's say I subtract this amount, this buffer, and I add this amount, this buffer, and still this is greater than, x is greater than y, then we can say that mu1 is greater than mu2. To make things more clear, what we can say is that to account for this kind of fluctuations, we need to take into account the size of random fluctuation in average of x and average of y when doing hypothesis testing. In this way, we'll be able to more accurately judge our assumption whether it is right or wrong. Let me quickly summarize what we discussed today. We discussed about two sample test and how it is more prevalent than single sample test. And for our assumption in hypothesis testing, we took a simple heuristic and saw that it may not be sufficient. We may need a better heuristic with some buffer on it. So that is for today. We'll do more knowledge sharing in later sessions. Thank you so much.